In this question, we're going to look at Earth's magnetic field. So we start off with the observation that the Earth's magnetic dipole moment is, well, this value here. So this is our mu value. So this is mu. Okay, so then let's start with A. The first question is, what is the magnetic field strength on the surface of the Earth at Earth's north magnetic pole? Okay, so the relationship that they're really getting at is, well, what's the magnetic field strength? And how is that related to mu, which is the dipole moment? Well, our relationship here depends on mu naught over 2 pi, and mu, which is our dipole moment, and z cubed. So this is the equation where we're looking at the field strength on axis with the dipole moment. Okay, and so we have these values, except for, well, what do we use for z? Well, there we're using the radius of the planet. And so the radius of Earth, I'll just use some astronomy notation there. Radius of Earth is about 6.38 times 10 to the 6 meters. Okay. So then we can substitute in our values. Here we'll have 2 times 10 to the negative 7 Tesla meter per amp. And then we'll have our value for mu, so 8 times 10 to the 22 amps meter squared. And then this will be all over our radius of the planet. So 6.38 times 10 to the 6 meters. That's all cubed. So magnitude here of the magnetic field will work out to be 6.2 times 10 to the negative 5 Tesla. So there we go. This question requires us to connect the concept of the dipole moment with the field strength, with an equation we've learned about. But really, I think the conceptual leap that we need to make is kind of applying that to a physical circumstance and recognizing that this z value is going to be the radius of the planet. Because we're treating the magnetic dipole of the Earth as being, at the center of the planet, deep in the interior, and we're pretty far from that up on the surface, so the distance there is going to be the radius of the planet. So that's A. What about B? So in B, what we're looking for is the current. Essentially, we want to have a current running around the equator that produces an equivalent magnetic field. So how do we do that? Well, let's remind ourselves what the relationship is between a current and a magnetic moment here. So we've got our mu, and that can be equal to the area of the physical cause of the moment and the current. And so the area here is going to be the area of, so we're going to have, again, we're modeling this as if we've got the planet, and we're going to have this current kind of around the equator here, and we've got this radius, And so we're going to use this as our area. So our area here is going to be pi r of the planet squared. Okay, so we've got pi r of the planet squared times our current. But really, we want this in terms of the current. So why don't we bring that area term down? And we know, in fact, what the mu value is, because we want that to be equal to what Earth's value is. So I'm just going to move this to the side. So we're going to isolate I. And so we're going to put things in terms of I, which is what we want. And we know that mu is going to be, what was mu? Mu is 8.0 times 10 to the 22 amp meter squared. And then we have our pi, and radius of the planet was 6.38 times 10 to the 6 meters squared. So we plug this in, and we get a value of 6.26 times 10 to the 8 amps. That's a very large current. I would not want to be responsible for producing that. But this makes sense. So just comment that this is a very large current. Does that make sense? It's probably sensible due to the scale here of what you're trying to produce, due to the scale of the planet and its magnetic field. So yeah, this is probably a massive, ambitious undertaking. And that's just getting back to the point that the planet's magnetic field is actually quite significant and is very important, because it protects the planet from all sorts of charged particles and that would otherwise potentially do damage to living things. So the question is not a particularly difficult application of some of these equations, but what it really does is force us to think about how to model this to the planet and recognize that connection. All right, that's it.